So today we're going to be continuing with our example of this irrational function here. Like I mentioned previously, a rational function is basically one which has a numerator and a denominator. And I said that this method that I'm teaching you to find the range of a function, it only works when we're dealing with rational functions. You can't use this method, for example, when you're finding the range of a quadratic function or a linear function. I already taught you how to find the range of a linear function in the first ever range video, so these recent videos have been about rational functions, and in the last part of this series on range, we're going to look at finding the range of a quadratic function. So we're going to be continuing with our example, which was question 10 of the February-March 2018 paper 12, and we're looking at part B. So we have our function here, g of x is equal to 8 over x minus 2 plus 2 for the domain x is greater than 2 and less than 4, and we've been told to state the range of the function g. So like I said to you before, whenever we're looking at a rational function, if we want to find the range of a rational function, we have to do some analysis using the domain, because the domain gives us the range. So we have to plug in these values into the function and see what's happening to our y values. We're basically trying to inspect what's happening to our g of x values by using the domain. Because if the domain gives us the range, we're going to use the domain to inspect what's happening to the g of x values so that we can figure out the range of this function. Because remember, the range of this function is basically telling us what's happening to the g of x values of this function. So let's look at this. So our domain is x is greater than 2 and x is less than 4. So x is never going to be 2, but x can approach 2. Because if x should always be greater than 2, if x should always be greater than 2, it can never be 2. However, x can be super close to 2. For example, x can be 2.01. Okay, x can be 2.01. Okay, x can be 2.001 or 2.0001, and so on and so forth. So x can get super close to 2, but it can never actually be 2. It has to be greater than 2, but it can be super close to 2. So the first thing we want to inspect here is what's going to happen to the g of x values when x approaches 2. Well, if we put a 2 here, 2 minus 2 is 0. 8 divided by 0 is infinity. Think about it this way. In one of my previous videos, I mentioned that if you have a number k and you divide that number by infinity, that's going to approach 0. Okay, that's going to approach 0. If you have a constant k and you're dividing that constant by the number infinity, your answer is going to get super close to 0. And I even showed this to you, and I said if you take your calculator and you start dividing a number by a very big number, divide 2 by the number 1000, then divide it by the number 10,000, then divide it by the number 100,000, your answer is going to be 0.00000002. If you divide it by an even bigger number, 0.00, and you will have an endless amount of zeros and then a 2 at the end. So you'll notice that your number is going to get super close to the number 0. So infinity here just means a very big number. So if you divide a number by a very big number, you're going to approach the number 0. So if you rearrange this, okay, if you rearrange this entire thing here, you're going to have k approaches 0 multiplied by infinity. Okay, you're going to have k approaches 0 multiplied by infinity because you're simply cross multiplying, and then what you're going to have is k divided by 0 approaches infinity. This result is very important. Okay, so whenever you divide a constant by 0, you're going to approach the number infinity. So by the same logic here, if x approaches 2, 2 minus 2 is 0. 8 divided by 0, we know that's going to approach infinity. Infinity plus 2 is just infinity. It's just going to be a very big number as well. So what we're going to say is, when x approaches 2, g of x approaches infinity. Okay, so as we get super close to 2, the 2.01s, the 2.001s, the 2.0001s, we're going to approach a very big number. We're going to approach infinity. and you can plug it into your calculator. Start from 2.01, okay, then plug in 2.001, then plug in 2.0001. As you get close to 2, g of x is actually going to approach infinity. So when you get super close to 2, your g of x is going to approach a very, very, very big number. So g of x approaches infinity. Now, what happens when x approaches 4? X can never reach 4, but it can get super close to 4. X should always be less than 4, but it can get super close to 4. It can be 3.9, 3.99, 3.999, 3.9999. Let me actually write that down here. Let's say, x can be 3.9, but x can be 3.99. X can be 3.999, and so on and so forth. If you plug these values into your calculator, 8 divided by 3.9 minus 2 plus 2, you're going to get 6.2. Let's plug in by the way, you should be doing this as well at home. 3.99, you would get 6.02. If you plug in this for x, you would get 6.002. You get 6.002. So you will notice here that when my x values approach 4, my g of x values are going to be approaching 6. And you can just look at this simply by saying, let's imagine x is 4. It can never reach 4, but let's imagine it's 4. 4 minus 2 is 2. 8 divided by 2 is 4. 4 plus 2 is 6. So g of x approaches 6. Just like what we did with the 2 here. We said 2 minus 2 is 0. 8 divided by 0 is infinity. Infinity plus 2 is just infinity. So when x approaches 2, my g of x values are reaching infinity. And when x is 4, 4 minus 2 is 2. 8 divided by 2 is 4. 4 plus 2 is 6. So when x approaches 4, my g of x approaches 6. So I know that if I restrict my domain from 2 to 4, I am going to restrict my g of x values from infinity to 6. What does that tell me? My x is approaching 6, but it will never be 6. I mean, my g of x is approaching 6, but it will never be 6. But my g of x is also approaching infinity, but it will never be infinity. What does that mean? It tells me that my g of x is always going to be greater than 6. It's always going to be greater than 6, but it's going to be less than infinity. And this is the range of my function. My g of x, it will never reach 6. It will always be greater than 6, but it will also never reach infinity, so it will always be less than infinity. So g of x is greater than 6 but less than infinity. And whenever you have a domain or a range that's written in terms of infinity on one side, you can always ignore the infinity and simply put it as g of x is greater than 6. G of x is greater than 6. This is correct. This is also correct. You can pick any one of them that you want to write. Any one of them is acceptable. And let us look at the mark scheme. So this is question 10. This is question 10, part 2. This is question 10, part 2. And there we have it. G of x is greater than 6. So that's how we find the range of this function. So we inspect the domain. And we see what the g of x values approach when we approach these two numbers here. So that's it for the end of the video, and until next time.